Hi. Welcome to the Department of Electrical Engineering, University of Maroochydore. Today's practical is breakdown characteristics of air gaps related to high voltage engineering 1. First of all, before moving to the practical, let's learn what this electrical breakdown is. Okay. What is electrical breakdown? Electrical breakdown or dielectric breakdown is a process that occurs when an electrical insulating material, subjected to a high enough voltage, suddenly becomes an electrical conductor and electric current flows through it. All insulating materials undergo breakdown when the electric field caused by an applied voltage exceeds the material's dielectric strength. The voltage at which a given insulating object becomes conductive is called its breakdown voltage and depends on its size and shape. In our case, the insulating object or dielectric material is the air, surrounded by electrodes. Here, you can see some examples for the electrical breakdown. In our practical, we focus only the breakdown of air gaps, which means air acts as the dielectric material. You will see how it happens in the practical later in this video. High voltage laboratory. This experiment is practically done in the high voltage laboratory. Compared to the other laboratories in the department, high voltage laboratory has a high risk. Before you step into the high voltage laboratory, you should know the safety procedures very well, since you are going to deal with high voltage. Okay. Here are some important things you should know about the laboratory. Indication bulb. There is a bulb in front of the high voltage laboratory to indicate whether there is an ongoing practical or not. If bulb is light up, that warns outsiders not to enter the laboratory area. Earth rod. There is a possibility of inducing static electric charges in the high voltage equipment. An earth rod is available to remove these charges after an experiment is done. All the remaining charges should be removed in both de-energized equipment and its nearby equipment before we get close to them again. In this experiment also, before changing the gap between electrodes, after a reading is taken, we removed static charges using earth rod. Earthed mesh and gate. The testing area is separated from the rest of ground floor area of the laboratory by earthed mesh. So, we can assure, beyond the mesh, it is safe. Remember to stay away from the mesh. If you are touching it, the risk is still same. After arranging all equipment for the experiment, the entrance gate is closed, and the earth rod is kept crossed. At the time the gate is properly closed, we can hear the sound of limit switch. You can see how we did these safety procedures later in this video. Alarm. Normally, we ring the alarm to notify people who are in the laboratory premises to inform the commencing of a practical. So, people who are in the ground floor of the laboratory near the testing area can stay away from the mesh. Emergency push button. Emergency push button will disconnect the power supply to all the equipment in the testing area as soon we pushed it. In the practical also, when it reaches the breakdown voltage and gap is broken, we pushed the emergency push button to cut off the power supply. Now that we have discussed the theory, let's move on to the practical. This is a figure of the control panel. Here we have the high voltage output display, the panel power on lock, on and off push buttons, and step up and step down push buttons. To start the operation, first you must turn the lock and wait until the output voltage value becomes 0. Then, you press the start push button. Then you can continue to increase the output voltage by using the step up push button. Once the breakdown of the medium occurs, press the stop push button to disconnect the supply. Before starting the practical, it is necessary to measure the atmospheric pressure and the temperature at the time of the experiment. This procedure is conducted for 3 types of gaps. First, we will consider the rod-to-rod gap. The figure shows the apparatus to conduct this experiment. To observe the effect of the gap length on breakdown voltage, we have to conduct the experiment at different known gap lengths. Now let's set the rod-to-rod gap length to 0.5 centimeters. Once the apparatus is set, we step outside of the apparatus area and close the gate for safety measures. Then, the voltage across the gap is increased. As you can see, once the output voltage reaches a certain voltage, the gap breaks down. We note down the voltage at which the breakdown occurs. Before conducting the experiment for a different gap length, we must remember to discharge the high voltage capacitor like this. Now, let's set the gap length to 1.5 centimeter and conduct the experiment again. Likewise, we conduct the same experiment from 0.5 centimeters to 4.5 centimeters in steps of 0.5 centimeters. Now we will consider the plate-to-plate gap. We follow the same procedure, but now we use plate-to-plate gaps. Let's consider the gap length of 1 centimeter. We increase the voltage as in the previous instances, and note down the voltage at which breakdown occurs. Again, we conduct the same experiment from 0.5 centimeters to 4.5 centimeters in steps of 0.5 centimeters. Finally, we have to consider the sphere-to-sphere gap. In the sphere-to-sphere gap apparatus, the gap length can be measured by the apparatus itself. First, we make the spheres contact with each other and observe whether the reading is at 0. In this instance, you can see that the reading is at 1.1 centimeters. This is the zero error of the apparatus. This must be considered when we take the next measurements. Now, we will find the breakdown voltage when the gap length between the two spheres is 1 centimeter. Once the gap length is set, we can follow the same procedure. We increase the voltage as in the previous instances, and note down the voltage at which breakdown occurs. Again, we conduct the same experiment from 0.5 centimeters to 4.5 centimeters in steps of 0.5 centimeters. Here are some sample observations that we received after conducting the practical. Use these observations when preparing your lab report. Thank you for joining this laboratory session.